Andrea? Andrea? Megan? Lauren? Kelly? Andrea? Kirsty?
Okay, today we're going to start on Unit 3, page 141. In Unit 3, the first thing we're going to look at is called synthetic division. And synthetic division is a shortcut for long division in algebra. It doesn't work in basic arithmetic. It works when we have x squared, x to the third, x to the fourth. What we're going to have here is some polynomial here. Polynomial just means many terms, and we're going to always be dividing by a binomial. Synthetic division only works if what you're dividing by is 1x to the first plus or minus some number. It would not work if we were dividing by 2x or if we were dividing by x squared. But we will always be using this sort of division for shortcut for synthetic division, we'll be dividing by two terms that have a 1x to the first. Now, it's not always going to be x squared here. It could be an x to the third, x to the fourth. We can have any number of terms here, but this has always got to be just a binomial with 1x to the first. The first step to synthetic division is we do a countdown on the exponents. Whatever polynomial I'm dividing into, it has to be in order where I can go 2, 1, and then 0. We have to have a number here on the end with x to the 0 power or no x. So I have to be able to count down 2, 1, 0. We have to do a countdown on exponents to make sure it's in the right order, and then we only write down the coefficients. So the coefficients here, I've already done a countdown, 2, 1, 0. The coefficients, this understood to be 1x squared, 1x, and a minus 2. So I'm just going to write down 1, 1, minus 2. We're only going to write down the coefficients. And then we are going to change the sign on the divisor, what number we're dividing by. So to show it synthetic division, we're not going to do a regular division up here at the top. We're going to draw a box below, but skip a line here. We need a blank line here in the middle. I've changed the sign on the divisor. It says I'm going to look at this divisor here, and I'm going to ignore the x for just a minute. Just like I didn't worry about x squared and x here, I'm going to ignore the x and change this to a negative 2. This rule says change the sign, so I'm going to put a negative 2. Now what we do is we bring whatever this first number is, we bring it straight down. This number doesn't change, it just comes straight down outside of the box. Then we multiply times negative 2. We multiply negative 2 times whatever's on the bottom, and we put it inside of the box. First number comes straight down, we multiply times negative 2, and put it inside the box. And then we add 1 minus 2 is a negative 1, and we multiply times negative 2. Negative 2 times negative is positive 2, and we add. So once we learn the setup, it's always bring the first number down, multiply, put it inside the box, add, multiply, put it inside the box, add. The last number here on the end is always our remainder. When our remainder is 0, this says this divides into there evenly. Now, our answer is not 1 minus 1. What I did when I did synthetic division is I ignored the letter x. But if you take this x squared here and divide by x, what it does is it reduces the exponent by 1. X squared divided by x gives me x. So my answer, I write my answer by reducing the exponent by 1. So instead of x squared, this becomes 1x to the first. Whatever I started off with, I ignored that x because dividing x squared by x just made it x to the first. So if this is x to the first power, I now have 0 x's. Now normally we just could have x here instead of a 1x, but I was just showing you where it came from. We reduced this x squared to an x to the first, and so my answer is just x minus 1. So when we write the answer, we remember just to reduce the exponent. Now here again, I've got x squared x and then no x's. We always do a countdown and it goes 2, 1, 0. We always have to be able to say 0 on the end. So I go 5, negative 12, negative 8. We write just the coefficients after we've done a check countdown. And then we change the sign here. So instead of a 3, I put a negative 3. The first number just comes straight down. We always just bring that first number straight down. Negative 3 times 5 gives me a negative 15. We add, and negative 3 times negative 27 gives me positive 81. Subtract 8. Now, this time there is a remainder. That means it did not divide evenly. The last number is always the remainder. We reduce it by 1, so instead of 5x to the second, it's now 5x to the first minus 27. And we write our remainder over the divisor. If I'm dividing and I have a remainder of 1, I put 1 over the divisor, 1 over 2. So your fraction here comes from the remainder over the divisor. Now this time when I go to a countdown, I go 3, 2, but it skips to 0. When I try my countdown, I have to be able to count down, so what I have to do is add a placeholder in here. If I've got a 3 and a 2, I have to add a 0x to the first, plus 11. I have to be doing a countdown. Not only does it have to go down, I have to put a placeholder for any missing number. 3, 2, 1, 0. Now, if I just add an x, I've changed it. But 0 times x is 0. Adding 0 doesn't change it, but 0 is your placeholder. So now I'm going to divide into 5 minus 6, 0, and 11. So the countdown is not only to check the order, it's to check if I need a placeholder. Now I changed the sign, so I'm going to make it a positive 2. It's always the opposite sign when I divide. The 5 comes straight down. Multiply by 2, put it inside the box. Add. Multiply times 2, put it in the box. Multiply times 2. Now here, it was x to the third, so I reduce it to 5x squared. That's the reason we were able to ignore the letters, because seeing that x to the third divided by x just reduces my exponent 1. And then I do a countdown, 5x squared plus 4x to the first plus 8. I do a countdown on my answer too. It went to square, so I go 2, 1, 0, and plus 27 over the divisor. That's a 2. Plus the remainder over the divisor. Now, over a fraction is just another way of writing divide, so this is just another division problem. But I have to look at the countdown, and if this is an x to the third, I have to add a 0x squared, 0x to the first, and then 27. I have to be able to count down all the way to 0. 3, 2, 1, 0 exits. So now I've got 1, 0, 0, negative 27, and change the sign. The rule has to be change the sign. Bring down the first number, multiply times 3, put it in the box. Add, multiply times 3, add, multiply times 3. So this time there was no remainder, and I go from x to the third, I go down to x squared, 3x plus 9. Now, synthetic division is just a shortcut. It's a technique we're going to use to solve polynomial equations. Polynomial equations, polynomial just means many terms. So I could have an x to the third or an x to the fourth. We're just going to have a larger equation than we solved before. To solve polynomial equations, you first list all possible roots. And a root is just a number for your solution or your answer. I'm going to list what are the possible answers. I have to be able to narrow it down to the possible answers, so I don't think that any number in the world could be a possible answer. And we'll show how to do that in a minute. We list all possible roots. We use synthetic division until we get a remainder of 0. We're going to have a list of possible answers, and then we're just going to start doing synthetic division. When we get a remainder of 0, that says that this term divided into there evenly. So up here on this example where I divided by x minus 3 divided into there evenly. If x divided by x minus 3 divided there evenly, that says 3 is one of the answers to the system. So as soon as we get a remainder of 0, that number is one of the answers. And once we've got one answer, we're going to write the reduced equation and solve. This equation up here was an x to the third. Once I get it down to an x squared, we know how to solve it. We can either factor it, we can go to the quadratic equation, but if you can get it down to an x squared, we then know how to solve it. So we're going to list the possible roots, we're going to do synthetic division. When you get a remainder of 0, that number is one of your solutions. We write the reduced equation and find the rest of them. Now, to list what are your possible answers. Before we can start to solve, we have to know what are the possible answers. And I'll have an equation in any form, ax to the n. Again, it can be to the third, to the fourth, to the fifth power. All we're going to be interested in the possible roots are the very first exponent, coefficient, and the last number. So it doesn't matter how many terms are added in the middle. For the possible terms, we look at this number on the end, which is b, and we take all factors of b divided by all factors of A. The number on the end is B. I look at every possible factor of B and divide it by every possible factor of A. Now, all of these should have both a plus and minus in front of them, because if this number here on the end is a positive, it could still be by multiplying a positive times a positive, or multiplying a negative times a negative. And if it's a negative, it says you have to have one positive times one negative. So all possible answers could be positive or could be negative. So the first group here, we're going to list the possible roots. We're not ready to try to solve yet. The possible roots, I look at this number on the end, and the factors are 1, 2, 3, and 6. I list all factors of the number on the end. All factors here are 1 and 2. So my possible roots say to take all factors here and divide by all of these numbers. It's all of the ones on the end divided by these numbers. I can see that when I divide by 1, it doesn't change everything. So I'm going to write plus and minus, divide every these numbers by 1, and I get 1, 2, 3, and 6. I really should have a plus and minus in front of every one of them, but that just reminds me that I'm going to try plus and minus. But I got these by dividing by 1. You take every one of these numbers divided by 1, and then you take every one of these numbers divided by 2. Now, most of the time you write answers out like this, and that's fine, but what I do is write answers below it so that I can see that I didn't skip anything. Dividing by 1 just leaves these numbers. Dividing by 2 gives me 1/2, 2 over 2, 3 over 2, and 6 over 2. Again, I don't care whether you write it out in a long line, but this just lets me see that I didn't skip anything. I took every number and then every number divided by 2. These are my possible answers. That say if it's not on this list, it's not going to be an answer to this problem. But when I go back and look at this, 2 divided by 2 is just 1. Anything that will reduce is already listed up here. It doesn't say this is not an answer. It says it's already listed in its smaller form. So if you see 2 divided by 2 is already listed, you can mark that out. 6 divided by 2 is 3. You can mark that out. But I go ahead and write them down, all of them down, so I don't skip anything, and then mark out any one that is listed somewhere else. Okay. Okay, on this one before I go on. Okay, on the next page, example 2, again, we're not trying to solve it yet. We're just trying to see what's a possible answer. So I take all the factors of 8, 1, 2, 4, and 8, and all the factors of 5. Now, you don't have to list them in order. You can say 1 and 8 and 2 and 4. Some people like to list it in pairs. I just like them in order, but it doesn't matter. The first one is always going to be to divide by 1, so dividing by 1 just leaves me 1, 2, 4, and 8. I always divide by 1 first, and then each number divided by 5. Now, none of those are going to reduce, so they are all possible answers. And again, I should be writing plus and minus in front of every one of them. I'm just not going to write it every time. Okay. Example 3. I factor 4, 1, 2, and 4, and all factors of 6. I start by dividing by 1. You divide by 1 first, so you always have these numbers. Divide everything by 2. Divide everything by 3. and divide everything by 6. Again, it takes a little more room to write them down, but writing them across, sometimes I accidentally leave out a number. Here I see that I take every number divided by 2, every number divided by 3. Now the key is to remember that these numbers go on bottom. 1, 2, 3, 6 are not your possible answers. These are only divisors. The last numbers go on top, the first numbers go on bottom. Now again, I look at anything will reduce. 2 divided by 2 is 1. That's already listed. Anything that reduce is already listed in its lowest terms. Even 2 over 6 is already listed as 1/3. So anything that will reduce, you can mark out because it's already listed in its simplest terms. We had to learn how to do synthetic division, and we had to learn how to write the possible roots before we can actually start solving the equation. Now here, instead of giving you an equation where it's equal to 0, they say find out where this is equal to 0. So it's just another way of giving you an equation. Usually it'll be written 0 equals this. Just like when we want to factor, it always has to be a 0 here. I can't do synthetic division when it says 2, but all of these problems are going to be given 0 equal. First step is to list your possible roots. Factor here is just 1, but the factors of 12, and they're just divided by 1, so that's all your possible roots. I list my possible roots. Synthetic division, I must do a countdown, 3, 2, 1, 0. Always check that my countdown is okay, 3, 2, 1, 0. So I go 1 to 2, now, what the possible roots do are tell us to what number to try down here for synthetic division. If I didn't know the possible roots, I wouldn't know whether to try 1 or 10 or 200, but these just give me the possible roots here. And the reason I put them in order is it's easier to start with the smaller numbers than it is to work with the 12, but it doesn't matter. I'm always just going to start with 1, and if that gives me a remainder of 0, that's an answer. Bring the 1 straight down. Multiply times 1, put it in the box. Add, multiply times 1, add, multiply times 1. Now, you're not always going to luck out on the first time, but whenever you have a remainder of 0, that says x equal to 1. Whatever you divided by is one solution. Now, if this was not a 0, I would go try -1. And if that didn't give me a 0, I would try 2. You just keep going down this list until you get a remainder of 0. You're not always going to luck out the first time. The reduced equation, because this was x to the 3rd, now x squared minus 12. And once we get it down to an x squared, we know how to solve it either using quadratic formula or see if it will factor. X squared is x times x. Minus on the end is 1 plus 1 minus. Minus 4x plus 3x does give me a -1. This was an x to the 3rd, and I do end up with 3 answers. Now, these answers were also up here on my list, But once I got it to an x squared, I didn't have to go ahead and try -1, 2, -2. I could use factoring to find these answers just a little bit quicker. Now, if this would not have factored and I'd have had the quadratic formula, if I used the quadratic formula, I might have ended up with an answer like 1 plus or minus square root of 2. That is not on my list. So when I do get an answer down here that has a square root or even an imaginary number, it might not be on my list. So this is not actually every possible answer. It's just every possible real rational answer. It doesn't list possibilities like 1 plus the square root of 2. But you'll always be able to find enough of the answers off of this list to get it down to x squared. And when it's down to x squared, we know different ways to solve from there. Again, I'm first going to list my possible answers, the factors of 12, 1, 2, 3, 12, all divided by 1. I don't know why I liked 12, but anyway. I do a countdown. 3, there's no 2. So I have to write it x to the third, 0x squared. If you forget that countdown, you're going to forget your 0 in the middle and you're never going to get the right answer. You have to go 3, 2, 1, 0. Now what I have to divide into is 1, 0, -13, -12. Bring the 1 down, multiply times 1, add, multiply times 1, add, multiply times 1. But you've got to watch here, these two negatives make it a -24. So that says 1 is not one of my answers. So I'm just going to go 1, 0, -13, -12. Now, if you try 1, don't forget to try a -1. You don't have to start with the smaller numbers. You can start with 12 or -12. I just think it's a little easier to start with the negative, or to start with the small numbers, but don't forget to try your negatives. 1, multiply times -1, add, multiply times -1, add, multiply times -1. So 1 is not an answer, but -1 is an answer. So I have x squared minus x minus 12. Now you could have kept on going down the list until you found 4 and -3, but sometimes it's a lot easier if we remember how to solve once we get it to an x squared. Factors of 12. And since it's 1 up front, these are my possible solutions. Always check your countdown, 3, 2, 1, 0. So it's 1, 83. Okay, try 1. Is 1 a solution? One didn't work. One doesn't work, I'm going to try negative 1. 1, negative 1. Negative 1's not a solution. One, 2, negative 1, 2, negative 6. Now, one thing you have to do is you have to go slow enough here you don't make any little arithmetic mistakes, because if you have trouble getting the first answer, it might be a long time before you find an answer that works. So just go slow and don't check your arithmetic. 2 gives me negative 1, negative 2, 0. So one of my answers is x equal 2, and I reduce it to x squared minus x minus 6. So I have 2, 3, and negative 2. Is that okay? My possibles are the factors of 4. Count down 3, 2, 1, 0. Now here what you might notice is that if I try a positive 1, if everything else is positive, adding is never going to get it to be a 0. You can try positive 1, but if I just keep adding to positive numbers, I've got to get a negative somewhere to add to 0, so I'm going to just try the negatives. If you tried positive 1, it didn't take very long, but 1 minus 1 is 2, minus 2 is 4, minus 4 is 0. Now this time, x squared plus 2x plus 4, 1 times 4 is not going to add the 2, 2 times 2 is not going to add the 2, so sometimes you have to go to the formula. If it factors, we know how to solve it. If not, we have to go to the formula, and the formula says x minus b, b squared minus 4ac. Now, everything we learned on test 1 about solving with x squared is going to come into play in this system. Once we get it down to an x squared, if it doesn't factor, we have to know another way to solve it. So I get negative 2, 4, minus 16. Now I'm going to come over to the side and say the square root of negative 12. Bring out an I. It's 4 times 3. It's 2I square roots of 3. Simplifying the square root of negative 12. So I have negative 2, 2I square roots of 3 over 2. Now we can never cancel here unless you can cancel both pieces. You cannot divide under the radical, but once it's outside of a radical, if you can divide both pieces, so I have negative 1 plus or minus I square roots of 3. Now again, anytime we go to the quadratic formula, these answers might not be on the list, but you will get enough answers off of the list that you can get it to x squared. And once you get it to x squared, you should know how to solve from there. What? Pull it this way? Is that what you needed? Okay. But like I said, if you have to go back to factoring and solving the quadratic formula from the first test, make sure you go back and review that, because you'll see this quite a bit on this test here. Now, when we get to x to the fourth, we have to find two answers by synthetic division. When I find the first answer, that would give me an x to the third equation. So I then have to find a second answer to reduce it to an x squared. What we want to do is use synthetic division until it's an x squared, then we know how to solve x squared. So if it's x to the fourth, I have to find two answers. So again, I'm going to start off with my possible solutions, 1, 2, 4, and 8. The factors of 8, but it's divided by 1. Do a countdown. 4, 3, 2, 1, 0. So I have 1, 3, maybe 2, 6.
There's no x to the third.
Oh, I'm sorry. This one should be 3x to the third. Let's just have a typo there. Did one work? If one does not work, try negative 1. 1, negative 1, 2, negative 2, negative 4, 4, negative 8. Now, I went through these pretty fast, but you've got to go slow enough that you don't make any arithmetic mistake. You make one mistake and find out that this one doesn't work, and it may be a long time till you find. Now, as soon as you get one answer, always use the reduced. Whenever you get a remainder of 0, do not go back to the original. We always have to use the reduced. Because if I were to write this in equation, this would be x to the third. Then once I find an answer for this, then I've reduced it to x squared. But if I find another answer for this one, I've still just reduced it to x to the third. So once you get a remainder of 0, we never go back to the top. And another thing we have to try is if negative 1 worked, try it again. Remember, sometimes when we factored, we got x equal 2 and x equal 2. Sometimes an answer can be more than once. An answer can have multiplicity 2. If you don't try it again, that might be your only other answer. 1, negative 1 is 1, negative 1 is negative 5. Well, this time it didn't work a second time. But if you don't try it, sometimes you're going to miss your other answer. So I'm still using the reduced. Never go back to the original. But if I tried 1 and negative 1, what's the next number on the list I want to try? I want to try 2. 1, 2 is 4, 8 is 4, 8 is 0. X squared or x plus 4. Now, if it's x to the fourth, I am going to have 4 answers. I found negative 1 and 2 by synthetic division. But I'll go ahead and list negative 2 twice to show that there are 4 solutions to this problem. The key to x to the fourth is to remember, always use the reduced equation as soon as you get a remainder of 0. When you get a remainder of 0, don't ever go back to the first. Use the reduced. And any number that works once, see if it works a second time. Okay, the first step is to list the possibles, the factors of 8. Four, 3, 2, 1, 0. Now, you don't always have to start with 1 and then go to negative 1. I just think that if they work, they're a lot easier. So I do start with 1 first. And you don't have to finish it out. As soon as you can see that's not going to be 0, you can quit. But as soon as I find a remainder of 0, don't ever go back to the original equation. Oh, thank you. You should try -1 again. But -1 did not work again, so I'm going to try 2. My reduced equation then goes x squared, if there's 0 on the x, plus 4. X squared, 0 x's, plus 4. Now you cannot factor x squared plus. You can only factor x squared minus, so you get x squared as a -4 when I take the square root. When you're finished, check how many answers you have. If you started off x to the 4th, you should have 4 answers. If you leave off your plus and minuses, you're not going to give me all of your answers. If you take a square root, you have to put a plus and minus. Again, you have to practice the new technique here of synthetic division, but you've also got to go back and practice factoring and quadratic formula, and if it's an x squared but no x, take the square root, but remember to put your plus and minus. So this section goes a lot back to what we did in the first unit, solving quadratic equations. Okay. In section 3.2, we're going to be looking at graphs of polynomial equations. Again, polynomial equations just means that we have many terms, so it's going to be an x to the 3rd, x to the 4th. To graph polynomial equations, what we're going to do first is describe the end behavior. Our end behavior, we're going to think of a straight line. This is when I have x to the 1st power, we had a straight line. If I had x to the 1st power, and I always had a straight line, one end was going up, the other end was going down. If it had a positive slope, it was always the right end was going up, left end was going down. We also want to think what happened when we graphed x squared. When we graphed x squared, we had a parabola and both ends pointed up. So x to the 1st had right end up, left end down. X squared had both ends up. The leading coefficient test is going to tell us about the end behavior. The leading coefficient is the number on the highest exponent. We're not only going to look at the number on the highest exponent, we're going to look at the exponent. If n is even, and this is when I have an equation in the form ax to the n plus, we're just looking at this original number here. We're just looking at the first number. If it's raised to an even power. If it's raised to the even power, both ends are going to go the same direction. And what we picture is x squared gave us a parabola, both ends pointed up. So just like an x squared, any even, whether it's x to the fourth or x to the sixth, both ends are going to be pointing the same direction. But if the number out front is positive, it's both ends up, like when we had a parabola. But if a was a negative number, it opened down. The end behavior says if it's to the even power, if the largest exponent is to an even, if it's a positive number, both ends up. If it's a negative number, both ends down. And to help you remember this, think of a parabola. If it's positive, both ends up, negative, both ends down. But if n is odd, it's going to be like a line, and it's going to go one end up, one end down. If they're even, both of them are the same. If they're odd, they're different. If it's positive in front, it's like a positive slope. A positive slope says the left end down, and the right end up. But if you put a negative up front, a negative then is a line going downhill, so it says the left end is up, right end down. So the first thing here, we're not going to be actually graphing it yet. We are going to discuss the end behavior, describe the end behavior. And I always think of it, if it's even and it's positive, think of a parabola. If it's negative, think of a parabola. If I think of these pictures, they help me to remember. X squared said they were both up or both down. If it's odd, if it's positive, it's a positive slope. If it's negative, it's a negative slope. And I just think of these little pictures to help me to describe the end behavior. Even, they are together. Odd, they're different. Okay, this one says 11x to the third. To describe end behavior, that's all that I look at. X to the third says that it's odd. Positive says left end does what?
Down.
Down. Right end up. If it's odd, they are different. Even, they are together. Negative 4x to the fourth. Even says they're the same, but negative says both ends what?
Down.
Even says they're the same, negative says both ends down. Odd says they're different. And by odd, I'm looking at this exponent, not the negative 5. I'm looking at the exponent. Odd says they're different, so I have to figure out what the left end does and what the right end does. But a negative slope says the left end was what? And the right end. Two x to the fourth. If the exponent's even, they're both. And if it's positive, both up. Now, we're going to discuss the end behavior, and then we're going to find the zeros. And the zeros are where y equals 0, or where they cross the x-axis. Oops. The zeros are where we set the equation equal to 0. When the equation y is 0, that's going to give you the places that you cross the x-axis. So again, we're not graphing yet. We want to find the zeros. The zeros are where you let y equal 0, and again, they are the x-intercepts. I guess I left room for it down here, and I didn't. Now, multiplicity is how many times an answer occurs. Or each zero occur. We had one while ago where x equaled a -2 and x equaled -2. X equaled -2 twice. If we have an even multiplicity, well, let's talk about odd multiplicity. My graph, if I have an odd multiplicity, is going to cross through at that point. If I have an odd multiplicity, we cross the x-axis. But anytime we have an even multiplicity, if I say x equal 2, x equal 2, what we do is we come to that point, we hit that point, but instead of crossing through the axis, we touch and turn. We cross through any point that just occurs an odd number of times. But any point that occurred twice, we touch and turn. That's when I solved equations and I said if x equal 2 and x equal 2, write it down twice. It's important to know that that answer occurred twice. Because when I go to graph it, it says I'm not going to cross through that point. I'm going to touch that point and turn around. Okay, here I want to find my zeros, and I want to discuss the multiplicity. The zeros are where this equation equals 0. And f of x is just another way of writing y. So a lot of times when you're graphing, it's easier to think of it as a y. So this equation is y. I want to know where it equals 0. So x minus 2 says x equal 2. X plus 1 says x equal -1. Now, to help you to remember how to graph these, write these as points because they were the point where I picked y to be 0. If you leave it like this, sometimes you forget what to do with them. So write these as points. These are called your zeros. They're also called the x-intercepts. Now, how many times did each one of these occur? They just occurred once. If they occurred one time, we are going to cross at that point. We're going to cross the x-axis. again here. That's the exact same problem, isn't it? Let's skip number 2, since it's exactly the same as number 1. Now, if it doesn't have an x, that doesn't give me an answer. 3 equals 0 doesn't give me an answer. So if it doesn't have an x, I ignore it. I have x plus 5 and x plus 2. Now, for just a second, I ignored the fact that this one was squared. I go back and I say, how many times did this answer occur? Well, that's the exponent here, so this answer only occurred 1 time. But how many times did this one occur? It's only written once, but that's understood to be x plus 2, x plus 2. So this one occurred 2 times. It's the exponents that tell us this. 1 time says I am going to cross at that point, but if it occurs 2 times, it says at that point we touch and turn. Again, to find the zeros, we start off letting it equal to 0. Now, if there is an x, that does give us an answer. When I divide by -3, I do get x equals 0. But you really should write these as points. They're going to help you a lot when you go to graph them. If you remember that I picked y to be 0, so these are points where y is 0. You go back up here and look at where you got 0. It occurred 1 time, so you are going to cross. Where you got the 1/2, it occurred 1 time, so you are going to cross. But where you got the 3, if it occurred twice, you have to write touch and turn. Example 5, when we let it equals to 0. Now, it's nice when it's already factored for us. Here, what can I factor out? So I'm going to factor out an x. and so x equals 0. Now, you can list it twice, or you can just remember that this one is a cross, but because this one occurred twice, it's going to be a touch and turn. Now, to solve this one, when it is x to the third, we could use synthetic division. But we also looked at some problems if you can factor it. Synthetic division will solve any equation, x to the third, x to the fourth. But if you can factor it, sometimes it's a little quicker. And if it is 4 terms, I'm going to try grouping. Now, if this didn't work, if I couldn't solve it by factoring, I would then go ahead and use synthetic division. And I think there's one on the homework that you do have to use synthetic division. But if you can solve it by factoring, sometimes that's just a little bit quicker. But if you never did get this factor by grouping, you could find one answer by synthetic division, and then you could solve it. So we've just given you more tools to solve. We already solved some by factoring. Now we learned if you can't factor, you can do synthetic division. So x plus 5 equals 0. And all of these just occurred once, so all of them are going to be cross. Okay, now we're going to put this information together, and we are going to use this information about end behavior and zeros to graph. It says we want to describe the end behavior, find the zeros. The zeros are where we let y equal 0. Find the y-intercepts where we let x equal 0. Now, we may need to find more points, we may not. Then we can graph it. So first I'm going to look at the end behavior. Remember, the end behavior we looked right here. If it's odd, they are different. If they're odd, the left end's going to do one thing, the right end's going to do another. If it's a positive up front, we think of a line with a positive slope. So the left end is going to go what? Down, right end up. If it's odd, I think of a straight line. If it's even, I think of a parabola. Now, we are going to let y equal 0. Again, a lot of these will factor, so if I want to try factoring before synthetic division, it might be just a little bit quicker. But if you had trouble with factoring by grouping, you can use synthetic division. Oh, that was a plus. I couldn't read my typing there. Now, all of these just occurred one time, so all of these are going to cross. Now I'm going to let x equal 0. And instead of f of x, I usually just think of that as y. F of x is one notation, but that is y. I've got 0 to the third, 0 squared, okay, I'm going to put these points on here, -1, 0, -1, 0, 2, 0, -2, 0. I also had a point at 0, -4. Now, I am going to look at my end behavior. My end behavior said left end was down, so I'm going to go over here on the left end and just put a little check to remind myself this left end's going to be down, but the right end was up. Now, those aren't actually part of the graph. It just helps me remind what I'm doing. Left end down, right end up. What we're going to do now is wiggle through the points. I'm going to go past the last point here on the left. And I know to start down. I could start up and wiggle through these points, or I can start down, and that's why the end behavior tells me to start down. I'm going to go somewhere past this point, start down, and cross through that point. The end behavior told me to start down. I see a point, I have to cross through it. If there's another point, I have to turn around and cross through that point. Now I've got a point down here, so I'm going to have to go down here and cross through this point. If I see another point, I have to turn around and cross through it. When there are no more points, I just keep going, and I should have ended up, and I did end up. The end behaviors tells you to start down and just cross through a point, turn around when you see a point, go through that point, turn around when you see a point. When there's no more points, you just keep going in that direction. And I did end up going up. If I'd have ended up going down when I should have ended up, I knew that I've done something wrong. The end behavior just tells you how to start. If you ever forget the end behavior, come out here and pick a number like x equal -4, multiply it all out to see whether you start up or down. If you forget end behavior, that's when another point tells you where to go. But we're just going to wiggle through the points. If you know where to start, you go through a point, turn around to go through the next point, go through the next point, turn around to go through the next point. This doesn't tell us exactly how far up or how far down we're going. I'm looking for the basic shape. If you can get the basic shape, calculus would tell you exactly how high up to go or how far down to go. Okay? Again, I just start by describing the end behavior. It's into the third. If it's to the third and positive, I think of a straight line. If it's odd, they're always different. So left end goes down, right end goes up. Let y equal 0. What can I factor here? So I get x squared, x minus 1. But this one only occurred one time, so it is going to cross. But the 0 occurred 2 times, so it's what we call touch and turn. So I'm going to make sure I'm very careful with the point 0, 0. I touch that point, but then I turn around. Now this time, what would I get if I let y be 0? If I let x be 0. And I actually already had that point. So if you saw that you already had where x is 0, you might not have had to go through this step. At 0, 0, what I'm going to do is I'm going to put an x through that point. That reminds me that this point is different at 0, 0. And I have a point at x equal 1. And my left end needs to be down, my right end needs to be up. So start anywhere to the left of this last point. But this time when I come up here and touch it, you turn around. You do not cross at that point. You touch it and turn around. And if there's another point, you have to turn around to go through that point. Now these should not be straight lines. You should see that they are kind of curved here. But this is what I call a touch and turn. You go to that point, You touch it, you turn around, and then if there's another point, you always have to turn around to go through the next point. Sometimes these are called wiggle bumps. We wiggle, but sometimes we bump off a point. Now, to find the end behavior, end behavior whenever I have a bunch of parentheses, I have to see what would happen if I multiplied all of the x's together. When it's multiplied out and we see x to the third or x to the fourth, we knew how to do that. But here, if it's not multiplied all together, what we have to do is look at just the x's, because we don't care what happens on the rest of it for the end behavior. So if I multiplied just the x's here, I would have an x times an x times an x, x to the third. We don't care about the rest of the terms here. We just care about the fact that it would be an x to the third. So if x to the third, what is my end behavior?
Left down, right up.
X to the third is like a line. Now the nice thing is, on my second step here, if it's factored, it's really already much easier to solve. X minus 3, so x equals 3. And all of these occurred once, so all of them are going to cross. Now, if you let x be 0, I have 0 minus 3, 0 plus 4, and 0 minus 1. And here, I have to multiply all of these together, and y is 12. So I have 3, 0, negative 4, 0, and 1, 0. Now, if I don't want to count up to 12, I can count on the x-axis, on the y. You can count by 2 or 3 or 4. 2, 4, 6, 8, 10, 12. But just put at least one label here. Sometimes you'll get very, very big numbers. You might have to go 5, 10, 15, 20. But always leave the x-axis counting by ones. Always count these by ones, even if you have to sometimes go, I might even have a number like 400. I might have to go 1, 2, 3, 400. My end behavior says down and up. Here's a point way up here, Here's my next point. Turn around, here's my next point. My arrow's not off a little bit. Okay, is that okay on number 3? Again, I have to look at if I multiplied all the x's together. And since this one is squared, I've got an x squared here, I've got an x here, and since this one is squared, I've got an x squared. You have to notice that this is squared, and this is x, and this is squared. So I'd x to the 5th. So it is going to be left, down, right, up. When I go to solve for just a second, I ignore that squared, so I get x equal 3. But then I look back, if this one occurred twice, I've got to notice that this one is going to be a cross. This one, a touch and turn. You don't have to write that down every time if you put some way to remind yourself this one is a touch and turn, but this one occurred once, so it's cross. This one's going to be a touch and turn. You don't have to write it down every time as long as you know those two are different. And if I let x equal 0, 0 minus 3 squared, 0 minus 1, 0 plus 4 squared. Is that 144? Again, I start left down, right up. 3, I'm going to make sure I put an X through there and remind myself, don't cross, you touch and turn. 184. Now, negative 144, I may want to count 50, 100, negative 150. Start down, but this time you just touch that point and turn around. That's why I put an X through it. That door is locked. You went to the door, but it's locked. You had to turn around. Here's another point. Here's another point, but you turn around, touch, and turn. Now, I put the checks for my end behavior first to tell me where to start. This tells me I started down. But also, I better end up where this check is, or I've probably missed one of my touch and turns.
Can you put it all the way down for just a second?
Like up here.
No, it's very down. No, I want it to the very top. Thank you.
Okay. Because this was x squared, x to the first, and x squared. Is that what it was? Okay? Now, when there's no parentheses, it's already multiplied out for me. It's only the parentheses I have to multiply it out to see what happens to x. I'll just look at x to the third Now this almost looks like you could factor it using two parentheses, but not when it's x to the third. That has to be an x squared where I can factor it. And if it doesn't look like I can factor it, I'm going to have to use synthetic division to solve. The synthetic division says I go. Synthetic division's where I have to do it. Three, 0, negative 4. These are points. I have a point at 1, 0, but the negative 2 occurred twice, so I'm going to have to remember that that one is going to be different. The negative 2 occurred twice. And if I let x be 0, most common mistake is to not touch and turn. Do not cross through that one. I put an X there to show don't cross it, but you do have to go to that point and turn around. Okay, on this one? That's not bad. Now this time when I look and see what happens when I multiply the x, I also have to keep that negative 2 up front, because that negative 2 up front is going to determine my sign. I have an x squared here, and an x squared here. I need to know that it is x to the 4th, but I also need to watch that negative up front. So x to the 4th says they're both the same. This time they are both going to be down because of that negative up front. Even though we're just looking what happens on the x's, we also have to know if it's positive or negative. Now I can factor here. But the negative 2 doesn't actually give me a point if there's no x. If it were negative 2x, I would have x 0. But this doesn't give me an answer. So x is 4, x is 5, Now, remember to look at this squared. The 4 is going to be a touch and turn, but when I factored it into x minus 5 and x plus 5, these each occurred once. Negative times negative is going to make it positive. 32. Someone check that on their calculator. Okay. both ends down. By checking both ends, it tells me where to start, and it also is gonna be a check, this I should end up down. Okay, start past this point, go to a point, touch and turn, cross. Okay, make sure you practice some on these homeworks. If you practice these, this one can be one of the sets that you can do well on the test, but if you don't do this homework, you will not be able to do these on the test. So make sure you do some practice on 3-1 and 3-2. Okay, we'll see you tomorrow. I meant to mention this in class and forgot. The number I circled is your average now. But if your final is higher, I'll drop this one.
Mhm.
So if I dropped this one, that's what you'd have.
Mhm.
So if we can ignore that first one, as long as we keep this work up, we'll be okay.
I know. Mhm.